Okay, now let's talk about how to describe interval of random values. Let's say you've got a sample, let's say 10 glasses of water from a small lake, and then you would like to analyze how much of chloride is in these samples. And of course, later we will learn also how to extrapolate this knowledge to the whole population. Well, what you can do, you can measure how much of chloride in each of the glass, so you will end up with 10 numbers, 10 different concentrations, let's say in milligrams per liter. So what you do next? Well, the easiest thing you can do is to describe these values as an interval, represent these values as an interval, and then describe what's going on in different parts of this interval. Usually the idea is first to find a center of interval. Very often most of the values will be somewhere around the center, and the more far you go from the center, the less chance that you will find a value there. Then you describe somehow a spread, how far these values can go from the center, and also what's going on in different parts of this interval. So let's say you have this is your interval, this is the concentration in milligrams per liter, and then you have some 10 values like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you find a center. You find how far you can go from the center, how far the values go from the center. And then you describe what's going on in different parts of your interval, how dense the values are in each interval. So let's discuss how to do that. Well, we will start with very simple statistics, which actually don't need any assumption about what's going on in your population. And these statistics are the following. First of all, it's minimum and maximum values, and the range. Range is just the difference between the max and the mean. Then median, which is a good estimate of a center. Then we will learn a little bit more sophisticated things like quantiles, quartiles, percentiles, and then end up with frequencies and cumulative frequencies. And at the end of this lecture, we'll talk also about density. So let's start with some statistics. Well, the easiest thing you can do is to order all your values as a non-decreasing order. It means the first value should be the smallest one, then the next smallest, the next smallest, the next smallest, and so on. In this case, you can easily find a mean, which is always the first value in the sequence. The maximum value will be always the last one, and then the middle value in this interval of the ordered values will be median. Okay, let me show you an example. Let's say we have a height of randomly selected 10 persons, and you can see the values here. So the first thing you need to do is to order it. So you can find the smallest value, so it will be 162. Then you have the next smallest, it will be 164, and so on. So these are ordered values. Now you can easily see that this is the smallest. So this is the smallest value. This is the largest value. So this is your mean and max. And then you have a value 177, which is exactly in the center. It's a median. It's median. Median always split your values into 50-50. So it means that you have 50% of the values below median and 50% of the values above median. And if you look at this, you can see exactly that you have 4 values below median, and then you have 4 values above median. So it's exactly in the center. Okay. You can also calculate range by just taking a difference between the largest and the smallest value. In our case, we have range 26. So the minimum height we have, it's 162 centimeters. The maximum is 188 centimeters. The range, how big the spread of the height values is 26 centimeters, and median is 177 centimeters. What to do if you have even amount of numbers? Well, in this case, the first procedure is the same. You just order the values, but now you can see that actually you don't have a particular value which can be a median. For example, if you take 176 as a median, you can see that you have 4 values below and 5 values above. If you take 177, it will be vice versa. So in the case of even numbers, even amount of values, you just take a middle point between 176 and 177. So median is in between, so you can just calculate it as an average, arithmetic average. So in this case, it will be 176.5. So that's how to calculate it. You can also represent these values graphically, and the simplest way to do that is a dot plot. Dot plot is, I have shown you already the drawing which represents the dot plot, where you have only one actually dimension, it's x, and then you have this scale on this dimension, and your points are represented as dots along this dimension. You can also show the mean and the median and the max as I shown here. So this is mean, and this is max, and this is of course median. So this plot tells you something about how symmetric the distribution is, right? So you can see that even though the median is located here and we have equal amount of points on both sides of the median, but we can see that this spread is a bit larger than this one. So it means that the distribution of the values is slightly non-symmetric.